Welcome to Career Concern YouTube channel. In this video we are going to discuss about competitive coding through Python. What is competitive coding, right? Competitive coding is mainly important for all cracking of interviews to enter in IT field. Plus, competitive coding plays a vital role for every programmer, every B.Tech student to get a job in good company. So right, in this video we are going to practice how to increase our skills to perform good in competitive coding. For this video we are going to using Python language for competitive coding. Competitive coding through Python. Why we chosen Python? Python is a simple language, any beginner can learn easily, and number of built-in functions so that it helps us to reduce the programmer's task. There are lot of advantages regarding to Python, so lot of beginners uses Python for competitive coding. How we can solve a given task? For this we are following a 5-step procedure. The 5-step procedure first comes with analyze, and the second step comes from conditions, and third phase variables, and fourth phase is implementation, and fifth phase is analysis with test cases. These 5 steps helps us to solve the given question easily and effectively. First one, analyze. What is mean analyze? In this we are going to analyze the question. We are thoroughly reading the question. First understand the given question and draw some conclusions like what they given, what we need to find, what they given, what we need to find. These 2 points you need to analyze from the given question. After drawing some conclusions in first phase, we will jump into second phase. What is second phase? Is called conditions. Conditions means to solve the given questions we have to satisfy some conditions. This definitely for every question we need to solve some conditions to get our required output. So list all the conditions that we require to get required output. And then third one is variables. We need to know all the variables that are required for our program to solve the question, right? We need to have a scope of how many variables we are using, how the variables are changing. Let's list all the variables that are required for our program. After completing first phase, second phase and third phase, we have some basic idea. We have some basic idea to build or to implement the code. In the first phase, we have some conclusions and we understand the question, and second phase we have all the conditions that we need to satisfy, and third phase we have all the variables that we are going to use in our code. So jump to fourth phase, implementing the code. Implement the code. The code may differ from one language to another language, but the algorithm is same. In every, if you find largest number of these of 2 given number, we use same strategy, that means we use same algorithm in every language, but syntax may differ. So we need to implement the code in whichever language that we are most familiar. Implement the code. From this we get the code. What we have to do next? Is this correct code or wrong? We don't know. We just design the code based on our assumptions and perceptions only. But what we assume is completely different from what the computer assumes, right? So the step is analysis with the test cases. What is this test cases? Like, we need to give some random inputs. We need to give some random inputs to the code. Here in examination we don't have any scope for okay, we need to give some random inputs. From these random inputs we are going to get outputs. We need to interpret at each and every line of the code which is going to come, what happens for the next, what happens the next. We need to analyze each and every part. If all the random test cases are passed, our code is 100% correct for now. Then we will go for interpretation and etc. and we submit them. If we get any errors in this case, again jump to analysis phase and analyze what are the errors, that we get, and check again the condition. Is all conditions are satisfied or not? If not, change the condition. Again check all the variables. Again make some amendments to the code. Again analysis with test cases until or unless we get the correct code. We repeat this 5-stage cycles. For this approach we are going to solve our problem. Okay, coming to next, we are going to solve with an example. In this video we are going to discuss all the hackerrank problems that are available under Python language, because hackerrank is a platform where there is a lot of challenges for coders and for companies also. So what is the task they given? Task, they given a year, and we need to determine whether it is leap year or not. Whether it is a leap year or not. If it is, return true, else return false. This is the condition, this is the question they given. We need to perform this, our code is to perform this task. Okay, and also they given input format. The input format is, we need to read only a variable year. We need to read year. This is the question they given to us, and how we can solve using our 5-step cycles. First is what? Analyze. Second is what? Conditions. And third one is variables. Just remember this. And fourth one is implementation. And fifth one is test cases. First step, just analyze the question. So given a year, determine whether it is leap or not. First we need to find what is meant by leap year. Everyone knows what is leap year. A year which we have 366 days. It's called a leap year, right? This is a leap year. What they give a year. We need to find whether the given year is leap year or not. First phase over. We draw some conclusions like, we need to find whether given year is a leap year or not. And second, conditions. What are the conditions that we need to satisfy for leap year? Just tell me. First one is the year should be divisible by 4. Right. If that year is divisible by 4, then we can say it is a leap year. If not, not a leap year. Just check in a Google or anything. Just browse. What is a leap year? What are the conditions for leap year? If the year is divisible by 4, we can say it is a leap year. If not, it is not a leap year. Again, we have another. If it is divisible by 4 and if it is divisible by 100, sorry, if it is divisible by 100, then here for these conditions we have another condition. Like if the year is divisible by 4, we can simply say if a year is not divisible by 4, we simply say it is not a leap year. If it is divisible by 4, we need to check another condition. Why we need to check another condition means because these are the steps we need to find a leap year. If the year is divisible by 4, and we need to check whether it is divisible by 100 or not. If it is divisible by 4, again it is need to divisible by 400 also. If these three conditions are satisfied, we will say it's a leap year. Okay, right? If these three conditions are satisfied, then we can say that the given year is leap year. If this condition is not satisfied, then we can say it is not a leap year. Okay. Another condition is if year is divisible by 4, year the year is again divisible by 100. If it is not divisible by 100, then no issues, we can write it as a leap year. Yes, okay. These are the conditions that we need to analyze. If the year is divisible by 4, we need to check whether the given year is divisible by 100 or not. If it is not divisible by 100, we simply say it's a leap year. Just understand the conditions. If the year is divisible by 4 and if it is divisible by year is divisible by 4 and if it is not divisible by 100, then we can simply say that the year is leap year. If it is divisible by 4, again it is divisible by 100, we need to verify that it is divisible by 400 or not. If it is only divisible by 400, then we can say it's a leap year. If not, it is not a leap year. If the given year is not divisible by 4, then we simply say it is not a leap year. Understand? These are the conditions that we get in the second phase. We need to analyze the conditions. So completely we solve 2 phases. Then what is one third? Third phase is collecting variables. Here what we need to do, what are the variables that we require? Only one, which is a year. Year variable is required. They given print true and false. True and false are available in Python, so we are no need to store them. So we need to read an year. So we have only one variable in this task. Okay, we completed 1, 2, 3 phase. Coming to fourth, what is its implementation? We will go with an approach of defining a function like whether it is a leap year or a leap of year. Def is a keyword which is used to define functions in Python. Okay. Def. First, what is we given a year, First, initial, what is initial condition? If year mod 4 were equal to 0, if it is equal to 0, what we do? We check with another condition. If with 100, if year mod 100 equal to 0, if it is also satisfied, we check another condition. Just observe the syntax also. If year mod 400 equal, if all three are satisfied, then what we are going to do? We just return true. Okay. Else, what we are going to do is, it is false. If the year is divisible by 4, but it is not divisible by 100, what we do? We just print it is an leap year, so we just return true. If the year is not divisible by 4 itself, so what we do? The else is under this one, this if, and this is else. What we do? We return false. This is our function which defines the leap year. Okay, fifth phase also completed. We implemented the code whatever we get from 1, 2, 3 phases. So coming to fifth last phase is test cases. We need to take some random inputs, right? Okay. Take one right test case and wrong test case. Let me take 2004 1 and 1991. 2004. First, check whether it is divisible by 4 or not. Yes, it is divisible by 4. 0, 4, 4. Yes, it's divisible by 4. We don't require any modulus, so it is divisible by 4. Here mod 4 equal to 0. Satisfied. This will satisfy or not? I think it is not satisfied. It is not satisfied. Okay. So it is not satisfied means we are just going to, what we do? We just return false. And we know that 1991 is not a leap year, right? Okay. Coming to 2004, it is solved by 4. We still know 2004 is a leap year. We need to prove with our code, right? We know 1991 is not a leap year. With our code, we proved it is not a leap year, right? This test case is passed. Our code completely satisfied for this test case. So we are checking this. It is satisfied with first case, year is divisible by 4, it will get 0. And coming to second one, 2004 divisible by 100. Is it divisible by 100? I think no, it is not divisible by 100. So what we do? If it is not divisible by 4, return true. Yes, we return true, which means it is also a leap year. From this, what we do? Whatever the 2 test cases we taken, our code gives the output correctly, which means this code is completely correct, right? Okay, we did not get any mistakes, or all the 2 random test cases are passed, so no need for again going for analysis. This is our complete final code. So just type it in the Python editor and just run it. This is how we can solve the problem by using our 5-step approaches. If we are able to analyze what is happening at each step, then we can assure that we are going to improve our computation skills, right?